Okay, in the prior example, we went through and showed how to set properties on the process that you're running. So specifically setting the override save path to a different folder than the default folder that the PXF run multiple vehicles calculates on its own. And that was done using the API that's on the single run. So when setting the cycle or process, we could pass in additional parameters. One thing that we can do then is if we look at all these vehicles, BISG, CISG, micro, BISG, micro, they are hybrid vehicles. So we have mild hybrids and micro hybrids. So what we could do is just say we'll turn on the SOC correction. So just as a demonstration, if we're running this cycle and we want to turn on one of the default SOC correction methodologies or algorithms, what we can do is we can do that by a similar process. And what we'll do is we'll turn it on for each cycle. So in this case, because it's on the process itself and it's on the class itself, we don't have to specify a path. So it's just a property on the PXF run cycle. So it's not a property on one of the classes that it's holding a reference to. So what we can do is set the property directly on it without setting the path. So what we can do is just pass in the property, which is SOC correction. So we can go through and do SOC correction and then pass in the parameter as a string. So we're doing that here. And I could remove this extra white space and just pass it in this way. So what we're doing is we're saying that we need a comma here. So what we have then is we're setting the cycle. On the cycle, we're setting this directory, and then we're also setting the SOC correction to true. So what I'll do here is I'll put in another folder. So I'll put in SOC. So we have Amber, development, results, SOC. So I'll add those results into an SOC folder just that we can see that those are the SOC corrected. And we have the vehicle name with SOC correction set to true. So this is the way that you could set parameters. If it's directly on the PXF run cycle or running a procedure, you don't have to pass in the path. But if it's on one of the processes subclasses that it's holding a reference to, so that's directory manager or save path manager, or say the building, one of those, you'd have to set it on the class directly with the path. In this case, we're just setting it here. So what I'll do is I'll let it run and we'll look at the results. So we'll save this as an example demo 5. We'll save that as demo 5. Actually, let's call this demo 6. It's the last one where we're just setting the save path was technically demo 5. Now we're setting SOC correction, so this could be demo 6. We'll let it run and look at the results. Okay, so the simulation's finished using the SOC correction. So what I'll do next is let's look at the results table that's generated. So if I go here and type results table and I do PRNT, we could look at the results. So each of the vehicles ran and the results are saved in the folders here, and they're matching the path that we gave, where we have the results folder and the SOC folder and then the actual vehicle name and then the result file. So what I can do is I could load this directly. So let's call this R for result. We do a load and we load the result. So what I can do then is plot the SOC. So I'll do r.timesimu. Then I'll do r.ess plant SOC simu. And we'll do a grid. And that will create a plot. So you can see the initial SOC of the vehicle and the final SOC of the vehicle. And the SOC correction algorithm, the one that we were running, what it will do is it'll modify the initial SOC until the initial and final SOCs are within a tolerance of each other. So they have to be within 0.5%. So what I could do is I could do the absolute value of ESS plant SOC simu. We do R dot. We'll take the final value minus the initial value, which is the first value in the array, and just confirm that it's less than 0.5%, which converting the percent into a fraction, which is what it's being used in the workspace, we get true. So the value, the initial and final are within tolerance of each other. So we know that this simulation ran, that the simulation completed. So that completes this example.